On pace versus a sprint pace. Space shuttle for me was you're kind of rocking and rolling for the first couple minutes while the solid rocket boosters are on, and then it smooths out and it's pure acceleration. The landing coming back in is super smooth because you're landing on a runway, and Soyuz to me was kind of the opposite. It was a really smooth ride uphill, but coming back was really violent, and pretty incredible that we made it through that, but they've been doing it for many, many years, and a proven product for sure. We do things differently down in Florida now than we did for shuttle, so it was just a whole different world. We kind of blended, I would say, the best things from shuttle during quarantine and launch day operations and the best things from Soyuz that we've learned over the years. And kind of now we have a hybrid of those really good things on launch day especially. I'm really excited about it. I love the Kennedy Space Center and all the teams down there that I've gotten to work with. I love it for our country, our nation, that we're launching out of the U.S. again. It's a great capability that we have, and just happy to be doing it again out of Florida. My name is Shane Kimbrough. I am the commander of NASA's SpaceX Crew 2 mission to the International Space Station.
Riding in the same car as Kimbrough is Crewdragon pilot and NASA astronaut Megan McArthur. She's about to embark on her second space flight, and this will be her first trip to the International Space Station.
Kijk. Kijk.
That's the path we're in. The space station has paved the way, and every future big space program is going to have to follow the same path.
And Megan have made their way up the tower. They're now climbing the stairs to the level where the crew arm is located, ground level of pad 30. Hoshide, Japanese astronaut, to another.
I meant to check this, but do you know when I was selected as an astronaut? 1990. So I was born in Tokyo, actually lived in New Jersey because of my dad's job. In high school, I went to Singapore for 2 years. Went to Keio University in Japan. Got my degree in mechanical engineering. And then right after college, I joined the Japanese Space Agency. I have dreamt of becoming an astronaut since my childhood and tried a couple.
Vehicles is very important.
Segment to place, for example, experiments on the outside of the Russian segment or to relocate some modules. So we are very excited as well to also work with our Russian colleagues of Roscosmos and Energia to get finally this European robotic arm launched to the space station.
Right. No, that's very exciting. We're glad to see some of the specifics of what he's going to be working on board. Can you tell us about the importance of our commercial and international partnerships with ESA?
Well, it's very important that we have this partnership going, of course, in the International Space Station. At one day, the ISS will come to an end. But for sure the partnership will continue, and that is already clear in the Gateway program now, and we hope to extend that further to the lunar surface with the astronaut, with the Artemis program, and also have European astronauts one day walking on the surface of the moon. So the partnership for us is extremely important to be able to execute our exploration program, but also the commercial partnership is very important because ESA wants to continue to fly astronauts to low Earth orbit even after the ISS. We want to be able to do research in low Earth orbit after the ISS, do technology development that we will need for further exploration after the ISS. But most probably it will not be the same configuration anymore as we have today. It will be in a partnership with the commercial sector. It's what we call the LEO economy. And so one of the tasks that we have as well at ESA is to help build this LEO economy so that we can also have a good and thriving future of astronautics, flying astronauts, research and science in low Earth orbit after the ISS.
Right. We have a lot to look forward to then from ESA. Frank DeVena, thank you so much for being here with us today. Now we're going to take it back to the KSC host desk.
All right, thanks, Jasmine. Teams are running about 16 minutes ahead of schedule, and hatch close will be happening momentarily. So we're going to go over to John Insprucker in Hawthorne. John?
Thanks, Marie. We are coming up on T-minus 2 hours, 12 minutes and counting. Right now, the Falcon 9 team is on console in firing room 4. They are preparing for their communication checks with the crew. That's due at about T-minus 1 hour, 55 minutes. SpaceX engineers right now, they're continuing to pressurize the launch vehicle gas storage bottles. These are composite overwrapped pressure vessels. They contain gases used to fill the tanks with hot helium as the propellant is drained out of the first and second stages. We're also storing helium and nitrogen gases on the vehicle. We use those to spin the Merlin engine turbopumps when we start an engine in space. For example, when we light the second stage engine after it separates from the first stage. We're also using gas for attitude control systems. Both the first and second stages of the Falcon 9 have an ACS system. And finally, the landing systems use the gas to help with the grid fins and then deploying the legs right before touchdown on the drone ship. Now, currently for Falcon 9, the countdown is proceeding nominally at this point. On board the Dragon spacecraft Endeavour, we heard the comm checks just a little while ago between Dragon team and crew. We've seen the astronauts rotate their seats to the flight position. We've successfully completed the suit leak checks. And we're watching right now as the hatch is coming down as part of the closure sequence of events. And then once we get the hatch closed, the SpaceX support team will perform a final leak check of that hatch. Now, once that leak check is finished and it passes, the team will then begin the steps to ready the access arm for retraction. Once they've got everything configured, the team will leave the pad by T-minus 1 hour at the latest. Now, T-minus 2 hours coming up here very shortly. Kennedy Space Center personnel will begin final sweeps of the flight caution and hazard areas. Right now, the only people that are inside the roadblocks in a perimeter around pad 39A are the crew and the SpaceX support team that you see on your monitor. And right now, as we get ready to bring the hatch down, we're going to go back to the team at Kennedy Space Center.
Thanks for that update, John. As you can see, we are preparing for the closure of the side hatch. The closeout team there in the black SpaceX flight suits that you see have performed a final FOD check, and they've gotten the final okay from the crew inside the capsule to confirm that they are indeed ready to go to space today. As you can see, the side hatch has just been closed. This is a little bit more complicated than it may seem. So it's this initial closure, and then there will be actual mechanical closure using a torque wrench, which we should see here momentarily. Might be, yeah, we can see that happening now. And then afterward, we will inflate the seal that's around the side hatch in order to do that leak check. We'll inflate the seal, apply a pressure basically, and make sure that the hatch is able to hold that designated pressure for a couple of minutes. And once that's done, we'll put the open part of the hatch that still remains. And like John said, at that point, the crew will then begin to prepare the crew access arm for retraction.
And I can't emphasize this enough. We've seen this time and time again with SpaceX. The written timeline, has very specific times laid out, but oftentimes we see that they're ahead of schedule, and that's certainly the case here.
Side hatch is closed and starting leak checks on schedule.
Okay, so we heard the announcement that